Hi, kids. Hey, we are me. I don't know why we, but I feel like we're on this together. So really, we today are going to talk about parallel capacitor rules. Okay, so today, hopefully, you will get parallelously close to really understanding and really increasing your capacity to understand capacitor circuits. All right, so hey, I have a parallel circuit, just like when we are talking about resistors. If you draw your equal potential lines, like here is my high equal potential line. Here is my low equal potential line. Do you see? Battery, red, green. Capacitor 1, red, green. Capacitor 2, red, green. Guess what? The voltage has to be the same. Okay, so like for a given parallel circuit, voltage is everywhere is the same. So in this case, Vt equals V1 equals V2 equals V3, and so on. Okay, so the voltage has to be the same for that reason. Because again, you could do loop rule. You want to do loop rule? Yeah, me too. I want to do loop rule. I mean, loop rule's fun. So if you start right here and you go around, hey, I first encounter the battery. So that would add voltage from the battery. And then, I don't know, let's go this loop. But if you look, do you see how this left plate, because it's touching the positive side, that's positive, that's negative. So I would go from positive to negative. That would decrease the voltage. And then, hey, I'm back at my start, which means Vt equals V1, and I can do the same thing for each of those things. I mean, loop rule, you gotta love it, okay? But that's your first part. All right. This is a parallel circuit. Why is it a parallel circuit? Because, well, the stuff's in parallel to one another. But a parallel circuit means you have more than one path for the charge. Or if we're doing resistors for current, but really with this, you have more than one path for the charge to go. Remember, charge pushes. And then it gets to here. Some of the charge is going to go this way, some is going to go this way, so that the charge is going to build up on this and this. Well, that means whatever comes out of the battery has to equal this plus this. Hence, our next rule, which is going to be, this is conservation of energy. Our next rule is going to be QT equals Q1 plus Q2 plus Q3 and so on. This is really just conservation of charge, conservation of energy, because, hey, I gained some energy per charge. That's what voltage is. And then I lost some energy per charge. Well, it has to end up being zero because conservation of energy. Where this is, hey, you know what? Whatever charge comes out, like it has to split. I can't lose any charge. This is conservation of charge. Okay. But then, if I want to find the total, if I want to find the total capacitance of my circuit, if you guys take a look, remember this is our most important graph. Okay, remember capacitance is Q over V. If I solve this for Q, I get C times V. Is everybody with me there okay? So instead of my Q's, if I say total times the total equals C1 times V1 plus C2 times V2 plus C3 times V3 and so on. But hopefully you're smart enough to recognize, I know, okay? Hopefully you're smart enough to recognize, oh look, all the voltages are the same because it's a parallel circuit. So I don't need my little, subscripts there. Oh, well that means all those V's are going to cancel. Goodbye, 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 goodbye. So I end up with CT equals C1 plus C2 plus C3 and so on. If you look on your equation sheet from the College Board, you will see where it says like this. Oops. Cp for the total capacitance in a parallel circuit is equal to the sum of the individual capacitors. Okay? There you have it. Now, if we want to make more connections, because It's so important to make connections in physics class, kiddos. Let's make some more connections. Remember this equation, dielectric, permeability constant, area over D. If you look, going from, hey, I added a capacitor in series. So if you add a capacitor, not in series, in parallel, my bad. Okay. If you add a capacitor in parallel, let's talk about what happens. Do you all see this circuit? I have 2 capacitors touching the battery. Now I have 3 capacitors touching the battery. Did I change the dielectric? I did not. Did I change the constant? I did not. Did I change the area? I did. I increased the area that is touching the battery. Hey, guess what? If this goes up and this stays the same, which it did, my capacitance has to go up. If you add a capacitor in parallel, the total capacitance goes up. Well, again, what is capacitance? Oh yeah, the capacity to store energy and to store charge. Well, that means if I have a greater capacitance, that means I am going to have a greater total charge, and I will have more energy stored in my circuit. Or if you want to do it graphically, you ready? Let's say this was for 2 capacitors, 3 capacitors. My graph has to be steeper. Okay, which then makes sense if you guys take a look at a given voltage. Let's say, I don't know, here. Do you see I'm storing more charge? Do you see if we look at areas, that area versus the big area, I'm storing more energy. All right. Bye, kids.